All right, welcome everyone to our 9th Scalable Pandas meetup. I'm so excited to be here with all of you today, and I'm especially thrilled that we get to hear from Devin Petersohn and to have him talk to us more about, teach us more about Ponder, specifically running Pandas on your data warehouse. Just for all of your knowledge, this meeting is being recorded. We're going to post it to YouTube afterwards. If that presents problems for you, you can email me at peter@ponder.io. But yeah, that's our intention. So this can be a community resource. So the agenda, will briefly recap meetup goals. We'll do some quick introductions. Then we'll dive into the main event, which is hearing from Devin. Okay, so just a little bit about the Scalable Pandas meetups. What are these meetups about? So these meetups are about helping people who are dealing with Pandas scale challenges, so working with especially large data sets or complex workflows, and then trying to create materials around those, going through case studies, sharing best practices. Who is Ponder? Ponder is the enterprise-ready Pandas company. We have our product we'll hear more about today is Pandas on your data warehouse. And we're the primary maintainers of the open source drop-in replacement, scalable drop-in replacement for Pandas called Modin, which has over 5.5 million downloads. Why did Ponder start these meetups? We started these meetups to build a community and generate content around dealing with these Pandas scale challenges. And I will say it's been so gratifying. This is our 9th meetup. It's been really fun to hear people tell their stories and to all come together and be able to commiserate and have common experiences. How often will these be held? These are held the 4th Thursday of every month. So the next one will actually be on the 23rd of March. February has 28 days. Turns out the math is very nice. 4 weeks from now is exactly the same day as today in March. How can I get involved? If you'd like to get involved, if you'd like to speak at one of these, you can email me at peter@ponder.io. Yeah. So there we are. Okay, so now it's my honor. I get to introduce Devin, which makes me so happy. So Devin is the co-founder and CTO of Ponder. So I get to work with Devin. I'm the chief of staff at Ponder. And Devin has a PhD in CS from Berkeley. Devin, so when he was at Berkeley working with the RISE lab, he created Modin, which is probably many of you know this. It's a drop-in replacement for Pandas with wide adoption. We're big fans of Modin at Ponder. Devin spent 4 years as a U.S. Marine. He was a Korean linguist there. And on a personal note, I just want to say, so I get to work with Devin often, and I was thinking about Devin and some of the things that I love and respect about Devin. And a story that came to mind was the last retreat we had was in November, and I was a data scientist before I came to Ponder, but here I don't spend a lot of time coding. I was making my first contribution to Modin, and I remember Devin sat next to me. In fact, I think he crouched. Devin, I think you crouched next to my chair for like half an hour or an hour, like walking me through. It was a namespace conflict, you know, like the creator Modin was right there, like walking me through my very first, like very basic Modin PR. I feel like that was, for me, that's sort of exemplifies who Devin is. Like he'll spend half an hour crouched next to you, helping you work through, like very enthusiastically helping you work through some code issues. So anyway, I'm so excited to hear from Devin today. And Devin, yeah, I'll turn it over to you.
Thank you. Thank you so much for the kind words as well. Okay, so I'm going to be operating in a Jupyter notebook. This is like a slide view of Jupyter notebook. You all can see my slides, I think. Okay, I didn't see any no's, so I'm going to take that as yes. And basically what I'm going to be doing is showing you what we've built, and we're super proud, super excited about what we've built. Very excited to show this to you. So it's basically Pandas API on top of Snowflake, and there's a super secret reveal later about other things that we've been working on that we're unveiling. So stick around because you're not going to want to miss that one too. Okay. All right. So I mentioned that you know, we've built this Pandas API for data warehouses at Ponder, and we have this internal abstraction that we call the data frame algebra, which is something that goes way back to our time at Berkeley. I wasn't the only person who worked on it. I worked with a number of other people who gave great input on that, and I think that the paper turned out really, really good. Happy to share that with anybody who's interested. Please feel free to ask questions along the way. Peter, we have folks here attending who can answer in chat, and Peter can also raise questions as they come up. So yeah, this is intended to be interactive as something like this can be. So please don't hold your questions for the end. Just go ahead and ask them. Okay, so I'm going to spend as much time as possible showing you functionality, because that's what I think is interesting. I don't want to go through a ton of slides, so I'm going to just jump right in. So the first thing that I'm going to do is create a connection and connect to Snowflake and to Ponder. And then you can see here that I am importing modin.pandas as PD. This is, because modin is a drop-in replacement. And I'm using pd.read-SQL, but instead of passing like a SQL Alchemy connection, I'm passing the Ponder connection. And so when I do this, we go ahead and collect some metadata, stage a table as a view, because nobody with this is going to be operating in place on production data. We create a view of the data so that there's no conflict between the two. And then I will go ahead and print it here, and you can see, yeah, that it looks exactly like it does in Pandas, 15 million rows. Pretty straightforward, right? It's just Pandas, and it's operating in the data warehouse. So that was Snowflake. I'm also going to show you BigQuery. I'm not going to go through each one twice, because like I said, I want to show as much functionality as possible. So I'll show you BigQuery, but everything I'm showing in Snowflake today also works on BigQuery. So yeah, this is go ahead, Peter, sorry.
And Devin, there was a request, if possible, to make the font slightly bigger. I don't know if that's,
yeah, so
if that will mess with.
I can do
that looks great.
I can zoom in. It may mess with some of the renderings of Markdown, but it's easy to zoom in and out on this. So if I need to zoom out, I might do that too. But anyway, so here I printed the BigQuery data frame. I have Snowflake and BigQuery in the same session right now. And so yeah, so now I want to kind of move on to order related operations and talk a bit about things. So people who spend a lot of time in Pandas know that there's an order associated with your data frame, right? If you do df.head, you get the same rows every single time. In a database, that's not always true, but with Ponder, when you're operating on top of a data warehouse, that is true. We do guarantee that the same rows that you print for .head will be the same rows every single time. These are the same rows that you saw in my previous print right here. So, and those of you watching on video can like pause and verify. And then the same with tail. So a lot of like data frame operators or data frame APIs have an idea of a .head showing just like the first 5 rows or something like that. But not a lot of them do tail, because not a lot of them are actually ordered. So so yeah, since we have that Pandas API, and I'll talk a little bit more about like the fundamental kind of abstractions that we have internally a little bit later, but since we have these like core abstractions that allow us to represent things ordered, we can do that in the data warehouse as well. Okay, so we can even do things like grab row 9 through 99. Now, in a database, what's row 9 mean? That doesn't really mean anything in a database or data warehouse, but here in a data frame, it does. And so if I'm ordered by something and I want to grab a slice out of it, I can. The same with rows and columns. I can do something like grab a little square out or something like that. So same semantics, same exact behavior as Pandas. Okay, and to talk a little bit more about order and about how we track order, I'm going to create this df sorted. And I also do want to call attention to how snappy this is, because this is quite snappy, right? Right now I put in the chat, but I'm in the Midwest. My data warehouse is on the West Coast, and it's the only amount of data that it's fetching from the data warehouse is just what we can print. And so yeah, it's very, very fast, as you can tell. Okay, so df sorted, I'm going to keep this around to kind of show you how order works. But
and Devin, there was a question in the chat, a few questions about related to caching. So there's, yeah. I think there's the question about, is there caching happening in memory? And then there's also this question of like caching maybe on the data warehouse side. There might be some confusion there.
Yeah, so so all the caching happens at the data warehouse side, basically. We're not pulling any data out to do any in-memory operations or anything like that at this stage. there's potential for things like that in the future, but in order to like not confuse everyone, basically all of the caching happens on the server side. So yeah, I mean, you can see that like this sorted data frame is going to be cached, so it's basically just fetching and just running it several times, and you see how quickly it prints. Every time it prints, it's fetching those rows. So yeah, it's not they're not cached here or anywhere, except we do caching on the warehouse side.
And is this, we have a question about, is this lazy execution?
There's lazy execution involved, but whenever I print, it does an execution. So and that's a good question, and it kind of gets I don't want to go too deep too early, but I will say that we have a lot of optimizations in place to where that like if you just want to see the first and last few rows, that's all we'll do the computation on. That's all the data warehouse will do the computation on. We generate very, very efficient SQL. So there's, yeah, it's going to be fast, and it's going to be efficient. So, and I'll show some chained operators later that kind of go into this and that sort of thing. So, and I also wanted to show sorted and grab like, a chunk of rows from the middle, just grab like the middle slice here on the sorted data frame. So we see that the rows don't go from 4 to 44 anymore because I did a sort based on this market segment attribute, and I'll come back to this because we're going to be doing a lot with the sorted. But okay, so one thing I wanted to talk about is index. Everybody loves Pandas index or hates Pandas index. I guess it kind of depends, but we support multi-index, we support index, and you can see here that we just set the index just like any other, just like you would in Pandas, and you can interact with it. So we can set the index here, and then we can do a loc based on that. Okay, I have a lot to cover, so I'm sorry if I'm moving too quickly. Group by. So there are also ordered versions of relational operators. So a lot of operators in Pandas have SQL operators in them, but there's also some kind of assumptions or order assumptions that go into these. These are built into our internal data model, and so we can emulate them in the database or the data warehouse. So when we do a group by, I'm passing the sort equals false flag because Pandas likes to sort by default. And so even when I do this, you'll see that the order is a little bit different. So yeah, it starts with automobile. It'd be funny actually if the DF ended up being sorted just randomly, because it could actually end up like that. But you'll see here that up here it's not sorted. It's based on the order of the original data frame. That's the order that gets output. But since we did already sort DF, even though we're saying sort equals false, it's still sorted. Okay, and this is exactly how Pandas would. If you have an assumption in Pandas, then you can have that assumption with Ponder. So that's really, really important to what we built. Okay, concat. Concat is union in a database. Everyone can imagine how to do a union or union all. But in Pandas, the union is actually ordered. So it stacks the second table below the first table. Here I've sliced the second table just to show you that we do indeed end at row 9999 of that original data frame, and just to kind of show that. And by the way, all this computation, everything is getting pushed into the data warehouse. So, and just to show that the union is happening. So that one took a little bit of time because it's grouping by something that there's like 15 million unique values. So so those of you who know about complexity will understand that like it takes more time the more unique keys there are. So anyway, you can see here that there are 2 of everything. This is just showing that we're actually doing the union, and that you can count on that. So okay, one-hot encoding. So one-hot encoding is something, get dummies, it's something that you really frequently want to do as pre-processing or feature engineering. You take I'm going to go and run it. You take a column that's a categorical or a string, and we basically elevated data into the metadata. So I used to have automobile, and now I have C market segment and automobile, and so on. And just to show you also related to order, we maintain the order even with something like get dummies. This assumption holds true in Pandas. It's going to hold true in Ponder. Okay, I'll come back. I'll do more with get dummies in a little bit. But first I wanted to show some matrix operations. So one thing you can do in Pandas is you can select by data type. That's really, really common. And then you can, I'm going to go ahead and print it. So I printed my numeric data frame, and now I can do something like min-max normalization. Now, min-max normalization in SQL is incredibly complex. I challenge anyone here to do it in less than 200 lines of SQL. But with Pandas, because Pandas is just such a powerful language, I can just type it like this, and Ponder handles everything, and it's all pushed down into the data warehouse. Okay, so one thing I wanted to show is CSV. Now, a lot of times you have data that's you have data that's a CSV that maybe you want to join in the data warehouse. With Pandas, you would pull the data out of the data warehouse. With Ponder, you can actually push the data into the data warehouse. So what we do is we determine the schema for you. We go ahead and stage that table. We upload the data into Snowflake or BigQuery, and then it's just there as a temporary table that you can interact with. So I have this df-CSV, but everything I do with df-CSV is going to be in the data warehouse. So yeah, and I limited this one to 50,000 rows, or sorry, 500,000 rows, just so that we didn't wait for my internet to like upload everything the whole time. So okay, so now one interesting thing that you can do is I had a CSV, I had a table in Snowflake in this case. I want to join them and do some interesting analytics with them. So I go ahead and just join like I would df.merge. This is the same Pandas syntax. I have this now I have this table here that I can interact with and access that partially started as CSV joined with my data in Snowflake. Okay, and just to kind of drive home this point, even like a join maintains the order in Pandas, so we maintain that order as well. Order is something that you can count on. A lot of times when you're doing sorts in a lot of data frame libraries or with a database, once you move on from that sort, your mental model might be that data stays sorted, but a lot of times the optimizers are just going to drop the sorts altogether and not maintain them. We allow you to basically count on the data to maintain an order throughout the life of your program. So okay, so datetime and DatetimeIndex. So I had my data that started as a CSV, but as it would in Pandas, it created it as an object data type. And now my data types aren't right? Because I want my date to be a datetime column. So just like in Pandas, I can overwrite that column with to datetime. Matt, I'm sorry, I didn't use assign this time, but assign does work in Ponder. So yeah, so and then when I go ahead and print this, you can see that we have a datetime column now, and we don't have to worry about that anymore. So what do you do with datetime columns? Often you're going to create a datetime index with them. And so even when you go to print the datetime index, this is exactly how it would appear in Pandas. There's like no visible difference to how you would interact with this, even if you just want to look at what the dates. Okay, and I'm going to go ahead and print the data frame here too, just to show you each row is corresponding to a date, and the index is as you would expect it. So so now I want to do a resample, and I want to resample based on every 4 weeks. I want to get the average total price of my data, and that's something that's really, really common. But in this case, it printed as a series. I don't really like that, so I can go ahead and print it as a data frame. And so this little exercise was to show you that there is caching happening, and that you're not going to be having to wait every single time for the whole thing to show. So the second time it was much faster than the first time. And the zooming is, it looks like cutting some off here, but yeah, I'll just zoom out for just a second. Okay, cool. So I have some secret stuff to show. Secret stuff being like we haven't publicized any of this yet, but now is a natural time to pause for any questions.
Yeah, we have a bunch coming up in the chat. They are around like data security implications, in particular, like with joining local file with the warehouse. Is the joining done locally?
Yeah,
we have.
it's not
Anyway,
done
yeah.
locally. Yeah, it's not done locally. Based on, so certain organizations have rules about what data can go to the cloud and that kind of thing. And so we can enable some guardrails to prevent unwanted data from going to the cloud if it started from a CSV or something like that. So different people have different security concerns. Some of them are like, I don't want to pull data from the cloud, and some of them are like, I don't want to push data to the cloud. We can control for both of those basically with Ponder. So yeah, but in this example, the join was done in the data warehouse. The data exists there in the data warehouse.
And then there was another question. There are questions about like overhead related to maintaining order. Yeah.
Yeah. So the reason why I'm doing this live demo is just to show you how long it takes, like what the latency is like. So the overhead is minimal, and we have a lot of optimizations in place. I spent my entire PhD focusing on data frames, and so like we have a lot of understanding of how to efficiently maintain order. There is an overhead, but the overhead is pretty well optimized, I would argue, and it's pretty evident by the latencies that you can see here. So
Yeah,
at least I hope so.
Okay, and then we have another one from Michael. Michael, do you actually want to come off mute and ask it?
Yeah, it sounds great. You can all hear me, right?
Yes.
Yes.
Mm-hmm.
Cool. Yeah. So the question is, we're seeing all these features and it's running against Snowflake, but this same API could be ported directly to Google's BigQuery without it'd be seamless from the user's perspective.
Yeah, as long as, so the only change would be the connection piece up front, which I showed. There's a slight difference in those, and like what your table name is, because I mean, unless you've named it the same, but yeah, it'd be exactly the same. There would be no difference. There'd be no difference in the output. Yeah, there would be no difference.
So then follow up, not saying you should have to release this right now, but then you would likely know, like from a cost perspective, like which backend service we should select. If from our perspective, it's all the same, it's modin under the hood. And so would you be able to offer those like performance, how that translates into cost, and which backend we should select? Because if we just care about translating data, yeah.
Yeah, so happy to talk in more detail about this, like more privately. But yeah, definitely.
I'm saying, like
yes, I don't know that we would publish anything because like we like publicly, but each workload is a little bit different, and so what your workload looks like is probably like each data warehouse has its specialties, right? And there's some on-prem databases as well that we've been working on integrating with as well that do that do certain things really, really well. So the answer is yes. There are some we can talk about it. But yeah, in terms of like publishing anything publicly, we currently don't have any plans to do that. It's very tailored. I would say, like our recommendation would be very tailored to what you're doing. So.
Cool. Yeah, thanks so much.
Yeah, no, thanks for the question.
I think you can keep going, Devin,
right.
and then we'll tackle more at the end. But that's funny. I will say, Michael, I hadn't considered that as a business line, which is like,
yeah.
Anyway, yeah, okay.
Okay, so so the secret stuff. So I'm not gonna toy with you all. We actually have a NumPy API that we've been building for Ponder, and it can actually push NumPy operations down into the data warehouse too. This is pretty early on. It's pretty it's experimental at this stage, and so you're going to see me here just enable the experimental functionality. If you recall, I said that we would play around with get dummies later, because get dummies is often something that you do before you want to train a machine learning model based on the features in the data. So what I've done here is basically do the get dummies on our market segment column, and then select numeric data types. And so now I only have the numeric data types. And I'll show you here, I've added to Numpy. This warning is just popping up saying like, you've turned on the flag. So this is running this is using Modin. It's not converting it to a Numpy array. And you can see that it looks exactly the same. All of these operations are going to be pushed down. So I'm going to create this array ARR. And just to show you what type it is, it's a Modin NumPy array, still very experimental. So yeah, we're super excited about this though, I want to say. So transpose. So I didn't really, when I was talking about data frames and the data frame stuff, I didn't really talk about transpose because it's a touchy subject for some folks, but with arrays, it makes total sense to want to do transpose. And here it's very natural, right? Like if we can do a transpose in a data frame and push it down, we can do a transpose in an array and push it down. I think people wrongly focus on the fact that you wouldn't want to ever do a transpose in a data frame, but rather that like our way of expressing computation allows us to do this with arrays and data frames and that sort of thing. So, so that's really awesome. And then there are things that aren't native in pandas that we can also do. Hyperbolic tangent is one thing, so we can compute this, and you'll see that when we print, it looks exactly like a NumPy array. This is just the same data, and it's still housed in Snowflake in this case. And exponential as well. We can do this, and these are two things that aren't a part of the Pandas API or anything like that, but they're things that we can push down because we can represent them in our core internal data structure. So okay, and then I also wanted to put sum because we can do sum, and numpy.sum is a little bit different than dataframe.sum. It sums the whole array if you don't pass an axis by default. So yeah, but this is an easy one, you can imagine, because data frames can do this as well. So all right, so at this stage you're probably asking if we are wizards and how this is even possible. We're not wizards. We wrote a blog post about this, and I encourage you all to go and check out the blog post. Basically, it comes down to viewing this problem from first principles. We took a first principles approach towards solving the idea of data frames and having our representation of data frames be the union between linear algebra and relational algebra, kind of the big mashup of the statistics world and the database world. And now we can do both in one place. I'm super excited about what all this kind of enables, and I'm like, you all probably have ideas too, and I would love to hear them. But I think this is going to enable a ton of new things that we haven't even thought of yet. So yeah, super excited. It's one of those cool things that 6 months ago people didn't even think was possible, honestly. So yeah, super excited. Check out our blog, and also yeah, if you have not signed up for the product, you're really missing out. Like, you should sign up. And play around with this thing. We want to make it amazing. We want to make it crazy good. It's really, really good. We want you all to try it, experience it, help us make it better, and help us yeah, just see the worlds of data science and data analytics kind of join forces and unite.
All right.
So that's like it for my little spiel. I'm happy to take as many questions as we have time for.
Okay, so many questions. This is awesome. So I think a few of them we should just tackle really quickly. One of them is this whole presentation, this demo was done in a notebook. Can you use this in your own IDE? How does that work?
Yeah. So this is just in my notebook here. I had it in a slides presentation. I had a plugin that I installed to show it, but this is a Jupyter notebook. You can use it in any IDE though. It doesn't have to be Jupyter. I didn't use any Jupyter Magic here or anything like that. It's all just running in whatever Python you prefer, Anaconda or otherwise. So yeah, there's no limitations on that front.
Okay, I think another point of confusion might be, how does all of this relate to open source Modin? So Ponder is different from open source Modin, but how do they relate to each other?
Yeah, so let me, I think this slide hopefully at least is a good illustration that the open source provides the API, but the connection and all of the pushdown pieces are what we built with Ponder. So basically this connection object that you're creating here allows us to push computation into the database or the data warehouse. If you're using open source Modin, it's going to pull the data out of the data warehouse and put it in memory like you would with normal pandas. So that's kind of how to think of the two. Basically, is that Ponder basically pushes computation directly to these, whereas open source Modin is basically pulling data from wherever it is and pushing it into these open source cluster managers that we support.
Okay, yeah, that makes sense. And others can ask questions in the chat as well. This is a good time for everyone. So, okay, so a question I have is, there's this blog going around, this idea going around that big data is dead. How does Ponder think about that idea? Yeah, what are your thoughts on that?
Yeah, so it's definitely a kind of catchy thing to say that big data is dead. Sorry, I'm just going to scroll to the landing page because I see some comments about sign up. So it's definitely super catchy to say like big data is dead. I don't think it really matters whether big data is dead or not. There's a big problem with like how people interact with data. And so like whether there are people moving to the data warehouse, there are people moving, from data warehouses on-prem, there's blog posts every day about one or the other. And to me, it doesn't necessarily matter. I think our focus at Ponder is on the user and unlocking user productivity. So, adding a Pandas API for like DuckDB, Postgres, Oracle, if that's what you want, right? Like these are all things that are, totally realistic and stuff we're already working on. So, yeah, I don't think it necessarily matters that whether big data is dead or not, or how you want to interact with things. I do think that what we're unlocking here is the ability to do big data analytics, which is like not really all that easy before now, right? Like before now, like even if you like just to kind of give a frame of reference, this really simple min-max normalization, very, very common thing that you want to do on statistical data. Sorry. Oh yeah, min-max normalization. So very, very typical thing that you're going to want to do. But this generates 200 to 300 lines of SQL, like just to be able to do this, because statistical operations like this just aren't natural to do in the database, but they can do them, and they can do them quite efficiently, actually. It's just a matter of how to express them. And so I think what's been missing is a really easy way to express computation, whether it is on big data or small data or whatever. We're kind of missing a big piece of the ecosystem there. So I'm sorry, I went off on a monologue a little bit about this, but like whether big data is dead or not, I think is kind of immaterial to the conversation of like how, like, there's a problem with interacting with data just generally, right? It doesn't matter if the data is big or small, right? If it's small, you can live in Pandas land and be happy. But once you cross that threshold of wanting to move to productionize it, or you're pulling it out of the data warehouse and querying it and then pushing it back into the data warehouse, like why did we create an ecosystem that does this kind of stuff? I ask myself these kinds of questions all the time. So yeah, hopefully that didn't come off as too opinionated, but yeah,
that's great. It's awesome. That's great. So I have other questions too. If people in the audience have questions, they can hop in. But I want to know if maybe Doris or Aditya, we have two other Ponder co-founders on the call. If there's anything you wanted to share, maybe starting with you, Doris.
Yeah, maybe I I think I posted this on the chat, but we're definitely in the early stages of like, we put out the blog post a couple of weeks ago around being able to run Pandas on a terabyte of data. In case you missed it, definitely go to our blog to check it out. And then this is our first public demo, so we're super excited to share this technology with you all, and definitely looking for feedback and thoughts on the product. So definitely come talk to us. Our inboxes are always open. And I also posted a link to the sign up page. So if you want to try this out, definitely sign up on the link, and happy to work with you all on how we can help you accelerate your Pandas and Numpy workflows.
That's great. Thank you, Doris. Aditya, is there anything you wanted to add? And then we have a couple more questions.
I don't have anything to add. We're just super excited about this new capability that we've unlocked. It took many years of research and development to get here, but I'd like to quote a database Turing Award winner, Mike Stonebreaker, when I say getting Pandas to run on a data warehouse is like gluing an apple to a pancake. It's like there's a fundamental impedance mismatch between Pandas and data warehouses, and we've kind of managed to make it happen. So I'm super excited by the progress that we've made, and very excited to have most of you try it out.
Yeah, I think it's kind of interesting that even very, very seasoned kind of people in the database community didn't think that this was possible. So super excited, super excited. There's a great question about new open source contributors in the chat here from Brad. So documentation help is always welcome. The new NumPy implementation is very new, and could also use some new eyes and new contributions. Yeah, so we have a Slack channel. We have an open kind of like Modin developers like channel group. You can feel free to go there, and you can say hi. We also have some issues in the open source that you can tackle, but I think it's just better to go on the Slack and interact with people. I think that's a lot more fun. So yeah.
Devin, so we have just a couple minutes. Can you talk about how you imagine Ponder fitting in with the modern data stack? So you have like DBT, you have Great Expectations, there's all these other tools. What's kind of the vision for how this plays with all of those?
Yeah, so basically the idea is that Ponder, we focused on the Pandas API, and now we have this NumPy API. The idea is that the user can kind of interact with data in a way that they're comfortable, and the underlying infrastructure is basically not something that they need to really worry about, right? With SQL, I don't have to worry about filtering my data down so that it fits on a single machine or anything like that, right? Because the data warehouse provides this. So I imagine that basically users will be using Ponder on top of the data warehouse and that sort of thing. So sorry, that wasn't a very coherent answer, but I think it's just a very natural fit here. I mean, the kind of modern data stack is very SQL centric, and I think what's been missing is a way to kind of have the folks who really, really like SQL and the folks who really, really like Pandas to kind of communicate in a way that makes sense, and to operate on the same source of truth, and to have them both kind of in the same room, being able to talk the same, speak the same language even against the data warehouse. And so I think that's effectively what we're building is a way for data teams to be more productive collectively, and to not have to think about and change the syntax for like whichever data source you're using for today. Like how ridiculous is it that like if I change from one data warehouse to another, I have to change my SQL statement, or if I want to use Spark, right, I have to pull the data out and put it somewhere else, and then after I'm done, I just push it right back, right? It seems like things are in a kind of a in-between state right now, and I think that what we're building is actually a way for folks to like stick with the APIs that they want to use, and just have it run on whatever is most cost efficient for the company, or whatever the company chooses to use for compliance or for security reasons, or whatever, and have all of the benefits of these data warehouses available to Python users. So that's what I think.
So I actually think that's honestly a great place to finish up. And we can stay on after we finish the recording and answer a few more questions people have them. But Devin, thank you so much. This is super exciting. I will say I work at Ponder, so I am biased, but I will say also I chose to come to Ponder because I thought this stuff was so cool. So coming as a data scientist, so this is fantastic. And everyone, make sure you go to ponder.io/product and sign up for the private beta, and we'll reach out with account information. But thank you so much. This is awesome.